right, so two things I want to accomplish. The first one's going to be a warm-up, and then we'll get to the last page of that P7 worksheet. So, let's be honest. Okay? Truthiness coming out here. Formative was not our best work. Okay? But it was the first one of the year. Okay? I get it. Okay? Making you remember stuff that happened last year in your previous math class, and I get it. Totally understand. I'm not mad one bit. Okay? All right? All that this tells me is that we just got to work a little harder. We got to remember some more stuff before next week, Thursday. That's what, So we might have to spend some quality time, either before school or in the resource center or stuff like that. Okay? Totally. It just means we got to remember some more stuff, but it'll come back. It's like riding a bike. It'll come back. Okay? And we learn from our mistakes. So, the very first thing that I would like us to do today is I would like us to warm it up, Chris. Okay? About to warm it up, Chris. That's what we were born to do. Okay? So I want the point slope equation for a line through those 2 points. Okay? And again, you can do this on the back side of that P7 note sheet, which is why I had to flippity-floppity. 2 and 4 and 6 and 8 and 10 and 12 and 14 and 16. Really, 7. True. All right, what's the first thing we got to do? We're going to find the slope. How are we going to find the slope?
M is equal to y1 minus y2 divided by x1.
So subtract the y's over subtract the x's. So my slope here is going to be 7 minus negative 5 all over negative 2 minus 3. That gives me 12 over negative 5. Correct? Yeet. Okay? So now I got the slope. I got the slope of the point slope form. I just need a point. Which point do we want to use? Either one. Doesn't matter, right? Okay? So, see, there he went. He just went past. He doesn't have hair, but he went past. There he is, right there.
I literally went, oh.
He's talking to somebody right now. Yeah. All right. So, my two choices are going to be actually here. Point slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. And again, if I go any further than that, I've changed forms. Okay? So if I solve that for y, now I've put it in slope-intercept form. Not what we're asking for. Asking for point slope form. So my two possible answers here are y plus 5 equals negative 12 fifths times the quantity x minus 3, or y minus 7 equals negative 12 fifths times the quantity x plus 2. Okay. Those are my two choices. One of them would suffice. Both is just going extra. Okay. With me? Okay. Questions on that? Love it. Okay. All right, so we're going to talk projectile motion today. Now, normally, what's up?
Actually, you have a question on that.
Yep.
Can you reduce that, or should you reduce that?
No.
Okay.
Like, reduce it to 2.4 or negative 2.4?
Well, you get the y, like getting the y by itself.
No, that's what I'm saying then. If you get the y by itself, now it becomes into slope-intercept form.
Okay, that's what.
Yeah. Yep. And we just want it in point slope form. Yep. If you got y, if you put it in y equals mx plus b, that's slope-intercept form.
Okay.
Okay? All right? Now, projectile motion. Okay? Here we go. So what we're going to do is we're going to take an object, and for today, we're just going to launch it straight up. Oops, I got to go away from underneath the light just in case I throw too hard. Okay? We're just throwing it straight up, and it's coming straight back down. Okay? Later on, we're going to launch this ball, and don't worry, I won't throw it at you. Okay? But we're going to launch this ball out. Oh, look at that, it did bounce. Perfect bounce. Okay? Right? We're going to launch the ball out, and we're going to be able to track it. Okay? And our test for that one, or one of our, it's a fun activity, fun lab, is going to be right up here in the front of the room. We're going to have a little teeny tiny ball bearing, because it's all about ball bearings these days. Okay? And we're going to launch it. Pew! And it's going to fly. And then right about in here, there's going to be a ring. And you're going to launch your little ball bearing through that ring. Okay? And then it's going to keep on going. And somewhere back behind Garrett over there, there's going to be a bottle cap on the ground. And we're going to hit the bottle cap. Yeah, there's a lot of math involved, but it's math that you can all do. Okay? And it's awesome. It's fun. Best day.
Tractor day is the best day.
What?
Tractor day is the best day.
Well, because you get free ice cream and cheese curds. Yeah. Maybe we can coincide the two.
Maybe we get
Oh, we would be setting the world on fire that day. Okay? So, anyways, this now we're back in the packet then. So you've probably seen this one before. This is for vertical motion. So we're launching a projectile straight up. It goes uppity, uppity, up. It comes back down, and down, and down. Okay? So S is the height of the object at any time. T is the amount of time that it takes for that object to launch. Okay? V sub 0, that's our initial velocity. That matters. V sub 0 is very much matters. Okay? I can take my projectile and I can put very little effort into it, and it's going very little distance. Okay? But I can put more effort into it, and I can hit the ceiling. Okay? It goes higher the more force I put into it. Getting back into the physica. Okay? Okay? S sub 0 is the initial height. Okay? So if I launch here at my height, so like let's say 5 feet off the ground, okay, I'm going basically just above the whiteboard, the top of the whiteboard, right? But now, if I launch from the ground at the same velocity, it's barely going up to the bottom of the whiteboard. Okay? All right? So it all depends on those things that you have to do. Right? So all of those play a role in the motion or the height of the projectile. Okay? So we have a projectile that is being launched straight up from ground level. What part is the ground level? That's our initial height. That's our S sub 0. And ground level would be what? 0. Excuse me, 0. So we are launching it from the ground. So that's 0. Okay? With an initial velocity of 272 feet per second. What part is that? Initial velocity. Yep. So that's V sub 0. Question number 1 asks, let us write an equation that will model the height of our projectile at any time t. Okay? So I'm going to start with S, because S is there, okay? Equals negative 16t squared, that's our gravitational constant, that one will always be, plus what? 272, is that what you were going to say before you were so rudely interrupted by the front table.
Yeah.
Yeah, exactly. Plus 272t. Plus what? Plus 0. So I don't have to write it if I don't want. Okay? All right. Love it. Great model for this situation. Okay? All right. When will my object launched be 960 feet up in the air? How do I do that one?
Plug 960 in for S.
For X, yep, plug 960 in for my height. I'm going to extend my arpeggio. Okay, so then that goes 960 equals, and then I got negative 16t squared plus 272t. Love it. Love every part of this. Now what do I do? Okay, so give me one way that we could solve for it. We could factor it, okay? If I'm going to factor it, what do I have to do? Set it equal to 0, get everything on one side, factor, factor, factor. Love it. Give me another way. We could get it equal to 0, and we could quadratic formula it. Love it, but not as in much love with it, okay? Give me a third way. We could complete the square. Again, love it, but not as much in love with it. Give me a fourth way. We could graph it, okay? So we could graph each side, find the intersection points, okay? Or we could get everything, set it equal to 0, and find the zeros, okay? All right? Either way, let's get it equal to 0. Since it said show all of our work, that to me says let's do it mathematically, not the graphically one. I'm going to take both of those t terms, and I'm going to move them to the left. Why am I moving them to the left? Because I want a positive on my t squared. Yep. Okay. So I'm going to go 16t squared minus 272t plus 960 equals their whole. Factoring, because we got big numbers. I don't want to plug those into the quadratic formula. Okay? Like 272 squared, not happening. Okay? So, can I factor it? Can I divide by 16 all the way through? Maybe. Is 272 divisible by 16? Yes. Is 960 divisible by 16? Yes, then let's do it. So if I divide everything by 16, I get t squared minus 17t plus 60 equals 0. And now it looks much more manageable. Okay? If it's factorable, I would need two numbers that multiply together to be 60 and add together to be 17. If I wanted to now use quadratic formula, I could do that because my numbers are smaller. If I wanted to now complete the square, I could do that because my numbers are smaller. But again, I wouldn't use completing the square on this one because 17 is odd. You could do it, but it ain't pretty. Okay? It's not like me. Okay? But it is factorable. T minus 12 and t minus 5 is what it factors to be. Now what do we have to do? Set those two equal to 0. I get 12 and 5. Whoa. Does that make sense? Why? So the t equals 5 is when the ball is going up. And then t equals 12 is when it's coming down. Okay, so this ball goes above 960 feet for 7 seconds. Right? Okay? So in answer to my original question, when will the height of the object be 960 feet above the ground? The answer to that would be 960 feet at t equals 5 and t equals 12. Now, if I graphed this scenario, I could actually graph it in two different ways. The first way that I would graph it, actually let me make these be the exact same height. Okay, those aren't the same height, but close enough. Okay? The first way that I could graph this is the actual path of the ball. The ball starts on the ground, it goes straight up, and then it comes straight back down. Okay? That is the actual path of the ball. But if I were to graph this one as height versus time, then my actual graph looks like that. Where somewhere in there, I've got 960 feet. So then this would be at 5 seconds, and this would be at 12 seconds. Right? It's a different perspective on the same graph. The actual path of that ball is just straight up and straight back down. But if I look at it over time, now I've brought into it another dimension. Okay? With me? Now, next, whoa, tap the brakes, wrong one. There it is. Now, the next one. When will the height of the object be at least 960 feet? Well, let's go back here. So let's go back to my graph. Just makes it easier because it's not at the bottom. Bam, bam. So this is height, and then 960. This is time, and then this is 5, and then this is 12. Okay. When is it at least 960 feet?
Between 5 and 12.
Inclusive or exclusive?
Inclusive.
Inclusive, okay, because it said at least. I would concur with that. So it would be between 5 seconds and 12 seconds if I was in interval notation. If I was in inequality, 5 less than or equal to t less than or equal to 12. Words between 5 and 12 seconds. All saying the exact same thing. Okay. Part D, when will the height of the object be at most 960 feet? Okay. So now when is it going to be below 960 feet?
0 to 5.
Okay, I like the 0 to 5 part.
And then 12 to
Ooh. Because you were about to say infinity, right?
yeah.
But what happens, oops, I put the ball away. What happens this one bounced, but this one's, our projectile stuck. What happens? It stops, right? So in how many seconds or at what time would it hit the ground again? Launch from the ground, when's it going to stick in the ground again?
17.
How'd you come up with 17?
It took 5 seconds to get up there, so it's going to take 5 seconds to get back down.
Took 5 seconds to get here, so it's going to take 5 seconds to get back down there, so this is 17. Okay? Parabolas, which we have motion is parabolic, or our motion is parabolic, okay, in regards to time. So parabolas are symmetric, so if it takes 5 seconds to get to a certain height from the 0, then it's going to take 5 seconds to get from that height back down to the 0. Okay? So all told then, whoops, double tapped it. Okay? So then all told, this becomes from 0 to 5, unioned with 12 to 17. And again, I would go inclusive there, just because on these ones, we're not very picky on the inclusive, exclusive ones, just because the wordage is
So you want the answers of these to be situational, not like the algebraical one, or let's go to infinity on each side?
situational. Yes. Yeah, projectiles would be situational. Yep. Okay? Now, I will tell you this here in the last couple of minutes of stuff. Okay? You have a test next week, Thursday. In here, in class, ready to go. Okay? The comment that I heard in my office yesterday was, thank God I didn't wait to start my P homeworks. Okay? Because there's 6 of them. You should at least be through half of them by now. Okay? If you're not, you got some work to do this weekend. Okay? Do not wait until Wednesday to do your homework. Okay? It will take you longer than what you think. And Wednesday is the big review day. Okay? So it would be really nice if you had it at least, well, I shouldn't say at least started, if you had it like 90% done by Wednesday, so that if you had questions on some stuff, we can use Wednesday as an answer session. Okay? A Q&A sesh on Wednesday. Okay? So it would be really nice to have it done by then. Okay? Monday, remember, you don't have class, so there's no videos to watch over the weekend this time, or this weekend. Monday, no class. Tuesday, we'll give you a review worksheet, and we will do a Barbie bungee lab. Okay? Great lab. Love it. Wednesday's question and answers. Thursday's test. Yeah, buddy? Love it.